Hey guys, welcome back. In the last tutorial, we talked about addressing modes and how to use them and how to utilize them, and the different options that we have when it comes to addressing modes and how to use them in order to achieve different things in our program. Now in this video, I'm going to show you how to use addressing modes in order to write a simple program. We're also going to talk about labels and how we can use them, and finally we're going to discuss some branching operations and compare operations. And all of that is going to be accomplished by writing 4 lines of code. It's going to be pretty simple. So let's first identify an array. Now, if you're familiar with C or C++ or other programming languages, array should be a very familiar concept. Array is just a list that holds a set of values. So I'm going to identify it as a constant, which means the value is not going to change throughout the program. So this array here is going to be a constant, and I'm going to identify it as hello world. I'm going to end the array with a 0, which means the last index or the last element of this array is 0. Now the index 0 of this array is H, index 1 is E, index 2 is L, and so on. And the last index is 0. Now what I'm going to do is I want one of my registers to point to this array. So how do we do that? Well, we know that this hello world is initialized somewhere in memory. So somewhere in memory, you're going to have H, then E, then L. So why is H and E not together in one place in memory? Well, because we identify them as byte. So every letter will have 1 byte of memory. In order to have one of our registers to point to this entire array or this entire string, we need to load the memory address or the memory location of array. Now we're going to see what that does exactly in the memory in a second. Now let's use our concept of addressing modes in order to iterate through this array and to get some values from it. So I'm going to load A with 1, x. Now what this is going to do, let's assume x is 10. Let's say that this hello world string is in memory location 10. So I'm saying 1 plus x, add that to memory location A. So what I want to do is first load the letter H into accumulator A, then letter E, then L. However, x here is never changing. X is always going to be 10, for example. Then we're going to add 1, so 10 plus 1 is 11. And we're always going to access that memory location, which is actually going to be letter E. And so this program is not efficient to actually iterate through every single element of this array. So what we need to do is use post auto increment mode and the addressing modes. And so we're just going to have a plus sign here. So the first time we load x, we're just going to load the value of x, which is 10, and that's going to be the letter H. Then we're going to increment x by 1 to basically point to the next element, which is E, then L, and so on. And we want to do this for many times. And so how do we do this? We're just going to keep running the program. If we keep running the program every time, x is always going to be reset. And so we need to have a label. This is where labels come in place. Label is basically just identifying a section of code. So I'm just going to call it loop for now. So everything that comes after loop is a section of code by itself that you can reference. And in order to keep running this loop label, you have to have a branching operation, which can be as easy as BRA, branch, and then the name of the loop. So what is this going to do is first initialize x with the memory location of array, then access A, do this operation, then it's going to go back to loop, which is this line here, and keep doing it forever until we stop the program. Now the program has been compiled and ran successfully. So let's step through this program and see what's going on. You can see here x and A has the default value of CB. So I'm going to step through this program. Now register x has C007, so we can assume that array is lying in C007. And I'm going to verify this. I'm going to go to memory address C007 and see what's going on in there. So that's interesting. I can see actually the string hello world in here, and each one of them has these different numbers. And so what are these numbers and what are they representing? Are they just random numbers generated by the program? Well, let's pull up this picture here. This is actually the ASCII value. And so every letter and some symbols have their hex values associated with them. So for example, the letter A, capital A, has the hex value 41. And so if you want to access the letter A, or if you want to display that in an LCD or something, you're going to reference the value, hex value 41. The lowercase a is 61. So the letter is different, has a different hex value when it's capitalized or not. And so our first letter is H. And you can see here, H has the hex value 48. And that's exactly what we see in our memory. After the H, we have the E, and that's 65. And again, we can see here in the memory, and so forth. So we have 6C, that's the L and L, 6F is the O, 20 is the space here. And so this hex value, you're gonna need it to be able to reference it whenever you're trying to access or display a letter or a symbol into a screen or LCD. So now that we've verified that, what we're expecting to happen here is that for A to be loaded with the content of X. So X we know is C007, and this is what this highlighted number here, which is 48. So 48 should be written into A right now. That's exactly what happened. And notice X became C008. So X was incremented by 1. And that's exactly what this 1 comma X plus here do. They add 1 to X. And so X is now pointing to the next memory location, which is 65. And so notice here, now we're at BRA loop, branch loop. So when I execute this program, it's not going to end or stop. It's actually going to loop back. So go back to whatever loop is, which is the instruction above, and then do this instruction. And so X now will be having the content of C008. And let me actually type C008. Although we can see it, which is the number right after C007, I want it to be highlighted. So it's this number 65 here, which corresponds to the letter E. And so 48 will be overwritten with 65. And again, X became 9. So we can keep looping through this. A is 65 now. After this, going to be 6C. Then 6C again, 6F, 20, and so on. Now let's make a small change to the array in order to kind of go into an example of conditional branching. So this branching here, it doesn't matter what happens before in the code, it's always going to branch to loop. What if we wanted to only branch, what if we want the program to only branch when something specific happens? So I'm going to change this array to have a space between each letter and 2 extra spaces between the O and the W, and then again, space between every letter here. Now let's say I want to load only the letters into accumulator A, ignoring the spaces. So what I need to do is first load B, basically have some kind of a flag with the memory location of X. So instead of A, it's going to be B. After we do this, we want to see if the value that we just loaded, is it a space or not? Now, how do we do this? Well, we know from the hex value, from the hex table, the ASCII table that we saw, that the hex value of the space is 20. So we can just compare the value of 20, or compare B. So this CMP means compare, and then B here, accumulator B, with the hex value 20. Now, this pound sign is to identify the number here. It's just going to be a number, not a memory address. This dollar sign is hex, so 20. So compare B with 20. Now, what we want to say is, in plain English, that if this is true, if B is equal to 20, which means a space, we don't want that to go into A. So we're just going to loop back into here and load the next value into accumulator B. So instead of having branch, it's going to be branch if equal. So BEQ, branch if equal to loop. Only if 20 is equal to B, only if there's a space, then loop back. Now with the current layout of the program, it's not actually going to do what we wanted to do for a simple reason. You can see here that we're loading the address of X into B and then we're checking, but then what's happening to X after that? it's actually being incremented. And so let's say we actually pass the check here. So let's say we're in the letter H, which is 48. And so we're checking that because the content of X is being transferred into B. That's okay, it's going to pass, so it's actually going to come to here and load that into X. However, we're actually incremented X by 1. So X is now pointing to this space right here. And then we're loading that into X, so X to A, so A is actually getting the space. And so to avoid that, we actually need to not use the post auto increment. We just need to use index addressing mode, with the index being 0, which means we just need to access X. However, how are we going to actually increment X? How are we going to look at the next letter and see if that's 20 or not? Well, we need to increment X somewhere. And so let's say that instead of branching back to loop, let's make another label, and we're going to call that 20. So we create another label, we named it 20, and we need to increment X here. So the instruction to increment X is INX. And then we need to, after we increment X, let's go back to loop. So when do we come to this label? We actually never call it from here, and you can see the branch loop here. So if you actually look at the logic, we never actually come to this label. We never come to this section of the code because we always branch back to loop. So this loop here, if the value is equal to 20, which means that we got in a space here, let's now ignore that and let's not load it to A and move to the next element, which is going to be E in this case for the first one. And so if it's equal to 20, go back to 20, or go to the label that I named 20. And then this label, so what's going to happen is going to come here, 20, come to this label, increment X by 1, which means it's going to look at the next address, and then it's going to branch to loop. However, we're not doing this here. So we're loading A with that value, but here it's very easy and safe for us to just increment X. So after we load that value, then increment X, and then we're going to be looking at the next element here. So now let's try this logic and see if it works or not. So here we go. In the compiling page, we can see the memory, we can see the instructions and the registers here. And so we know from previous experiment that the address is going to be C0007. So let's just jump into there. And you can see here the hello world. So we have the letter H here, which is 48. Then we have a space, 20, then E, 65, then space, then letter, then space, then a letter, then space. And so let's first load X with the value here, which is actually C010 in this case. Then now let's load B with the value of X. So it should be pointing to the first letter, which is H. So we should actually expect B now to become 48. And that's exactly what happens here. Now, 48 is not equal to 20, so this compare statement is going to fail. And so we said if this is equal, then go to 20, but they're not equal. And so it's not going to 20, it's actually just going to go to the next instruction. And so we're going to load A now with 48 here, and then go back to loop and do the same thing again. Now this time, you can see here that we incremented X right after we loaded into A. And so X was now pointing to the next letter, or the next character, which is actually a space character, which is 20. So B has 20. Now we're comparing it to 20. It is going to be true. And now this instruction is going to actually occur. We're going to jump into this label. Now watch this. We jumped into the label 20. X is C011. We're going to increment it. Now it's C012. Then we're going to branch back to loop. And now look at the next element, which is 65. So B now has 65. Compare this to 20. It's not 20. So we're not going to jump into this label. We're going to load A with that value and increment X. And then we can do this over and over again. You can see here A only, if you look at A now when I quickly go through this program, it does not load any 20s. It only loads the letters. You can see here, every time that we see a 20, we just move on and don't actually load this value into accumulator A. Thank you guys for watching, and I'll see you in future videos.